When resistors are connected in series, the same current flows through each one. To find the equivalent resistance, we simply add them up. R equivalent equals R1 plus R2 plus R3, and so on. This makes sense because each resistor adds more opposition to the current. Now, since the current is the same through every resistor, the voltage divides proportionally. The voltage across R1 is I times R1. The voltage across R2 is I times R2. And the total voltage equals V1 plus V2, which is I times the quantity R1 plus R2. This leads us to the voltage divider rule. V1 equals V times R1 over R1 plus R2. The larger the resistor, the larger its share of the total voltage. When resistors are connected in parallel, they share the same voltage across them. The equivalent resistance follows from 1 over R equivalent equals 1 over R1 plus 1 over R2. For two resistors, there's a handy shortcut. R equivalent equals R1 times R2 divided by R1 plus R2. This is sometimes called the product over sum rule. Notice that parallel resistance is always less than the smallest individual resistor. Since the voltage is the same, the current divides inversely to the resistance. The current through R1 is V over R1. The current through R2 is V over R2, and the total current is I1 plus I2. This gives us the current divider rule. I1 equals I total times R2 over R1 plus R2. Notice the opposite resistor appears in the numerator, not the same one. Here are some practical shortcuts for parallel resistors. First, R equivalent is always smaller than the smallest resistor in the group. If you get a larger value, double-check your work. Second, if both resistors are equal, say R and R, then R equivalent is simply R over 2. Third, if one resistor is much larger than the other, say R2 is 100 times R1, then R equivalent is approximately equal to R1. The large resistor barely affects the result. Keep these rules in mind. They're great for quick sanity checks before you even pick up a calculator. Let's work through a mixed series parallel example. Here's our circuit between terminals A and B. We have 12 ohms and 4 ohms in parallel. Their combination is in series with 3 ohms, and that entire branch is in parallel with 6 ohms. Our goal is to find the total equivalent resistance. The strategy is to simplify from the inside out, one pair at a time. Step 1. Start with the inner parallel pair. 12 ohms in parallel with 4 ohms. Using the product over sum formula, 12 times 4 over 12 plus 4 equals 48 over 16, which gives us 3 ohms. So we replace the 12 and 4 ohm parallel pair with a single 3 ohm resistor. The circuit now has 3 ohms in series with 3 ohms, and that combination is still in parallel with 6 ohms. Step 2. The 3 ohm resistor from step 1 is in series with the other 3 ohms. For series resistors, we simply add 3 plus 3 equals 6 ohms. Now our circuit has simplified to just 2 resistors, 6 ohms in parallel with 6 ohms. Step 3. 6 ohms in parallel with 6 ohms. Since both resistors are equal, we can use our shortcut. R parallel R equals R over 2. 6 over 2 equals 3 ohms. Or using the full formula, 6 times 6 over 6 plus 6 equals 36 over 12. Which confirms 3 ohms. So the total equivalent resistance between A and B is 3 ohms. Let's recap. For series resistors, R equivalent is the sum, R1 plus R2. Current is the same, voltage divides proportionally. For parallel resistors, use product over sum, R1 R2 over R1 plus R2. Voltage is the same, current divides inversely. Remember, Parallel R equivalent is always less than the smallest resistor. Equal resistors in parallel give half. And for mixed circuits, simplify from the inside out. In the next video, we'll use these tools to study power and energy in circuits.